closing comments. In very simple way, what we do, we consider business problem at the decision point. And the decision point, we have here usually subject matter expert who will make this decision, and this decision will transfer our problem from state 1 to state 2. Right? That's a very straightforward understanding, top level. You can explain to your spouses or children how it works. That's what we do. But then we can see what tools do you use. We usually apply rule engines or machine learning engines or optimization, constraint solvers and linear solver engines. And now we got in our disposal LLM-based tools, AI agents, and probably soon we will have some other engines what we even don't know. But we can add here just hard-coded decision engines written by programmers long time ago, or they continue to build new tools, and that's what we have in our disposal. And it's up to us to decide which of them, which combination of these tools to apply. But apparently, what we all can confirm from decision camp is that a hybrid use of different technology is a preferred way to go. But in reality, we apply this decision only in one point in a time. And if we consider that we're dealing with operational repetitive business decision, so we actually have the entire timeline, and in each point we apply decision, and this our problem is in different states. For example, what Martin just demonstrated, everything is changing in runtime. And it could be probably decision also could change. So if we look on this timeline, we actually have to make many decisions. And that's what Arash mentioned about continuous decision modeling and decision making. So this is our more realistic picture, and it means in different points in time, we should be able to make different decisions, or we can make in one decision, we should consider consequences of this decision, for this decision, for this decision. I just will mention my favorite example. We also did a warehouse management system, but we sent different, in optimal way, we found which trucks to load with today orders. But if it was Wednesday and we found the optimal combination of trucks, and let's say usually when warehouse did this order fulfillment system with 42 trucks, our optimal solution on Wednesday, let's say here, we made it only 39 trucks. We saved a lot, and we sent this in optimal way. We were happy, warehouse was happy, but then 2 days later, let's say this was Wednesday, this was Friday, suddenly new orders came, but we already don't have in our fleet this truck what really needed for this, and we have to delay this order, or we have to use 2 trucks instead of 1 trucks. So optimal in one moment can be not optimal, or actually worse than optimal in another moment. And we had a lot of examples of this during our decision camp. And this is everything deals with certain uncertainty. And our objective is to keep the overall process effective. The same thing in not logistic, consider insurance. Or loan, let's say loan origination problems, the most typical one. We're looking on risk management over life of the loan. And we need to consider making the decision right now may affect our bottom line. The same thing with insurance, with all other problems we have. It's always we should look on long-term effectiveness of our decisions, not just one. So it means that it's not necessary to make the best decision at each point of time. We can make not the best, but close to best or good enough decisions here and here to make overall decisions much more effective. And this is certainly one of the most important problems, and the more we're in this business for many years, and I can see they become more and more important because people already satisfied with one decision made in certain point, but how to support the entire process, and we need to make sure that our system is in process of ongoing improvements. Something what late Eli Goldratt introduced long time ago, and it again becomes more and more important as we implementing our systems. And based on a particular decision problem, a smart human will configure and apply different combination of our tools. And so here we have a very good application for agentic AI, and probably agentic AI, this is our nearest direction for improvement of our decision intelligence systems. And I also wanted to stress that all attempts to automate problems like this, 100% automation from the end-to-end automation sounds good, but it sounds to me as communism. I'm originally from a communist country myself, and I know that these good intentions don't lead to good results. So we have to be careful and probably lower our expectation a bit. And